Okay, question 5 from the Fall 19 exam is a lovely story about Harold and Maude. So we have Harold, who lives 10 miles north of school. So I'm just going to put the school here, and then 10 miles north, we'll put Harold's house. I'm just going to draw Harold. There's Harold. Okay, so leaves his house and starts walking towards school at noon, and he's walking at a rate of 3 miles per hour. Okay, at the same time, Maude, who thought they were meeting earlier in the day, they're not very good at communication. I think there's a moral here. Decides that Harold is a no-show. So she was at school. She leaves school biking west at a rate of 12 miles per hour. That's going to be Maude. She's on a bike. I'm not very good at drawing bikes, but she's smiling because she's on a bike. So that's my symbolic rendition of biking. Okay. I want to know, how fast is the distance between Harold and Maude changing after 1 hour? Okay. Is the distance between them increasing or is it decreasing at that time? Okay. So basically, at every moment in time, we're going to have a right triangle that looks something like this, where we're going to have the school here at the right angle. We're going to have Harold up here. So I'm just going to call this H and let H represent Harold's distance from school. And then Maude's going to be over here. So I'm going to call this M, and I'll let that M be Maude's distance from school, and D can be the distance between Harold and Maude. So all three of these things are changing. So they're all three functions of time, but they always form a right triangle. So I will always have M squared plus H squared equals D squared. The Pythagorean theorem always holds. Now, when that's a relationship between functions of time, I can take the derivative of both sides, and I'll get a relationship between their derivatives. And I was given some information about how these sides are changing, so hopefully that's going to tell me how fast this side is changing, because that's what I want to know. Okay. So if I take the derivative with respect to time of both sides, I'm really using chain rule here, because M squared, that's a function composition. That's M, Maude's distance from school, which is a function of time, plugged into the squaring function. Same thing for H squared, and same thing for D squared. So the derivative here, the derivative of the outside part, the derivative of the squaring function is just 2M, times the derivative of that inside part, which would be M prime. Plus, then we'll have 2H, H prime, and that equals 2D, D prime. Now, D prime is what I want to know, so I'm going to have to plug in for everything else. Okay. Now, remember, they left at noon, were asked about what happened 1 hour later. So, after 1 hour has passed, if Maude was going at 12 miles an hour, she will have gone 12 miles, and since she started at school, that's her distance from school. So I'm going to have 2 times 12, and then M prime is how fast Maude's distance was changing. Now she's traveling at 12 miles an hour, and I can see her distance from school is going to be increasing, so her derivative should be positive, so that's going to be 12. Plus 2 times, now we've got to plug in for H. Now, in 1 hour, Harold has walked 3 miles, but that doesn't make H 3, because that would be his distance from his home. H is representing his distance from school. So if he started 10 miles from school and he's walked 3 of those, he's now 7 miles from school. He's walking at a rate of 3 miles per hour, but be very careful here because H prime is negative 3. Harold's distance from school is decreasing because he's walking towards school. So you want to remember, in these related rates problems, we're almost always given the absolute value of the derivatives, and we're just told in words the direction in which things are changing. So we need to interpret the problem to see the appropriate sign to attach to those derivatives. Okay. Now, this will equal 2 times I need to plug in D, and then I should be able to solve for D prime. Now, to figure out D, I'm going to just use the fact that at this particular moment in time, I've got a triangle where this side is 12, this side is 7, I can then solve for d. So this would be 12 squared is 144, 7 squared is 49. So the distance at that moment in time would be the square root of 193. Okay, excellent. I think I'm going to just divide through by 2 just to make the arithmetic a little bit simpler. I can cancel a 2 from each of those terms. And now I've got 144 minus 21 equals root 193 d prime. So that's going to be 123 over root 193 is equal to d prime. So that's the rate at which the distance between them is changing. You'll notice that that's positive. Because that's positive, that says that the distance between them is actually growing at this moment in time. So Harold moving closer to school is causing the distance between them to decrease. Maud moving away from school is causing the distance between them to increase. And at this particular moment, the combination of how far away each of them is and how fast each of them is going, the overall distance between them is increasing. Okay. So I can say, and I want to always answer these questions in words. Okay. So the distance between them is increasing. So that's actually answering the second part of the question right there, at a rate of 123 over root 193. And of course, if I want to rationalize that and say 123 root 193 over 193, I could. Let's make sure we get the units. The units are going to be the units for distance, and we were measuring all of our distances in miles, divided by the units for time. And our other rates were in miles per hour, so this would also be miles per hour.